It's time to check your energy resources review so that you can prepare properly for your energy resources quiz that's coming up. So let's start out with the question about renewable, non, and perpetual, and what do those words mean? So renewable means a resource that can replace itself through reproduction. A non-renewable resource is the opposite. That's question 2. It cannot replace itself through reproduction. And then number 3, a resource that will never run out, or you could say it's constant, is called perpetual. And sometimes on graphs and charts, you'll see renewable and perpetual used interchangeably, used kind of to mean the same thing, but in our class, we have differentiated between them. So now, for questions 4, 5, and 6, you could have used different examples than I did. I'm telling you, though, some of the examples I used are on the quiz, so you may want to add them right to yours in addition to what you put. So for question 4, examples of renewable resources would be trees, corn, and fish. And corn, obviously, we eat to feed animals, but also corn we know is used to make biofuels, like ethanol, and all of those things can reproduce. Now, number 5, I want to make sure you have fossil fuels on your list. Maybe you listed them specifically, like coal, oil, natural gas, gasoline, kerosene, methane, but fossil fuels are considered non-renewable, even though they come from plants and animals. That's ancient plants and animals. And so a piece of coal can't reproduce to make another piece of coal, for example. Now, uranium, I do want on your list. That one's going to be on your quiz. Uranium is important as an energy resource. Remember, that's what they use at nuclear power plants, and it is found in rocks, so it is non-renewable. Now, I will say it's not limited in supply. It's readily available on our planet, but it's still non-renewable. And then aluminum, like to make my Coke Zero. Here, I've got one. Right, the aluminum to make my Coke Zero cans, that is found in rocks, so that would be a non-renewable resource. Now, examples of perpetual resources are sunlight, water, and wind. And again, those things are never going to go away. Keep in mind that sunlight is really causing the wind, the uneven heating. And then water, I know that water doesn't exist always in the same form, but the amount of water on our planet is going to stay steady, whether it's ice or liquid or vapor. Okay, so now let's get into questions 7 through 12. So we've mentioned this already. What's the solid fossil fuel called? It is coal. Now, what is the liquid fossil fuel that's taken right from the ground? So you could have put petroleum or crude oil. And then, by the way, like gasoline is a liquid fossil fuel, so is kerosene and diesel fuel, but those things are in petroleum and have to be extracted out at an oil refinery. So the liquid fossil fuel taken directly from the ground, you need to have petroleum. Okay, or crude oil, that means the same. Okay, now what about the gaseous fossil fuel taken right from the ground? That's natural gas. And then for question 10, that's when we get into the idea of refinery. So at an oil refinery, gasoline, diesel fuel, kerosene, you might also have a jet fuel in that answer. Those are things that petroleum can be refined into. And then methane, butane, and propane, those are all chemicals that are within natural gas, and natural gas refineries are pulled out of there. Okay, so now question 12 is an important one. How do we get fossil fuels? How are they created on our planet? And they are from the buried remains of plants and animals over, and this is important to add, stop and pause me if you need to, over a long period of time. We're talking for most fossil fuels, tens of millions of years to get buried deep enough in the rock cycle to have the right amount of heat and pressure to solidify coal into a fossil fuel or to make oil or natural gas. Remember, coal is the one that's primarily plant material, so forming right now in swampy areas, and then natural gas and oil, those are mostly decomposed animals, sea animals, or animals on land that took a river to the sea to be buried and decomposed. Okay, so now number 13. 3 traits of all fossil fuels. This comes from your fossil fuel notes. They're all energy sources, and that's why they're considered natural resources. That's how we use them. We get energy out of them. They're all non-renewable, the fossil fuels, and they're made of carbon. Now, here's an important note. Ready? And you've heard me say this a bunch. Well, if a fossil fuel is made of carbon and we burn them, the oxygen from the air, right, carbon plus O2, that would result in CO2 or carbon dioxide. So when we burn a fossil fuel, carbon dioxide is always made. Okay, now we know that there are lots of alternatives to fossil fuels. And so the first one is on our list, number 14 here, is nuclear is the right answer. The energy comes from splitting uranium atoms. So that's where the heat's given off, right? And then the water can be boiled to turn to steam, to turn the turbine to activate the generator, which makes the electricity. Okay, now number 15, energy from the sun, of course, is solar. Number 16, burning firewood and poop or corn pellets or even biofuels, that's biomass. Remember the prefix bio means life, so burning a once living thing. Number 17, falling water, hydroelectric. So we hear the hydro there. Remember, that's when they build a dam and then the water falls down to turn the turbine. Indirect solar energy we mentioned already is wind. And then question 19, what energy uses heat from the earth? That's geothermal. So literally magma close to the surface is boiling the groundwater to create the steam. Okay, so at this point, you should have everything correct on the front side of your review. Let's do a flip. So I kind of expected that question 20 would be a little bit of a challenge. So when you opened your energy resources inquiry, there were descriptions of these, and I asked you questions like about carbon dioxide, renewable, non, or perpetual, but you also did some research towards your decision chart. And so you would have discovered more pros and cons at that point. So let's go through them together. So what is a good thing about coal? Like, why are we using coal in this area to produce electricity? It's really because in this area it's inexpensive. You might have called it medium price because there was a pretty big range, but because coal resources are close to us here in Central Ohio, the transportation piece is not expensive, so it makes it pretty cheap. Now, look at this though. We've mentioned it. The bad thing is it creates carbon dioxide and other air pollutants. Now you might be like, Mrs. Fickus, why don't you just say CO2 is an air pollutant? Because I wouldn't say it is. Carbon dioxide is a greenhouse gas, right? And we need some of it, or Earth would simply be too cold. But also different air pollutants like sulfur and nitrogen oxides, which can cause something called acid rain and particulate matter. You know, like if you burn firewood, you get soot. The same thing happening at a coal burning power plant. Also, coal is non-renewable. Now we have to be careful there. It's kind of a bad thing, but both coal and natural gas reserves are still pretty plentiful. So I would say the worst con is the CO2 and the air pollutants. Do you notice natural gas is identical, right? And it makes sense because that's a fossil fuel, so still cheap in this area and actually less expensive than coal overall now. And then that's why more power plants are going to burning natural gas instead of coal. And it still does create carbon dioxide and air pollutants. Now, you remember that natural gas creates less carbon dioxide than burning coal, but it still makes it. Okay, so what about nuclear? Nuclear is not carbon-based, it's uranium. So the great thing about nuclear power is there's no CO2 given off, and there's no air pollutants that would be coming out like of the smokestacks. Now, the biggest negative is when the fuel rods have been used up. That means when all the uranium in the fuel rods have been split, you do have radioactive waste to deal with. And that's generally buried and generally doesn't cause a problem, but it's definitely a concern. Okay, so biomass, that's like burning trees, poop, even like biofuels, pretty cheap. And also it's renewable, unlike the fossil fuels. But like the fossil fuels, biomass is carbon-based, so you still get carbon dioxide and other air pollutants. Okay, now let's go on to the next list. So this would be the final four: wind, solar, hydroelectric, and geothermal. Do you guys notice something about the pros, right? They're all identical. Perpetual energy resources, meaning never ending. And also, I want to be clear here, when the actual electricity is created, there's no carbon dioxide or air pollutants. During the construction or for example, or the building of a dam, there may be, but once you're ready to make the electricity, there isn't any. So those are really great pros. So what's the problem? Really, for wind, it's only available in some regions. Now, power lines can transport that electricity, but it needs to be in a place that's windy a lot. Solar's the same thing. Remember, if you looked at that one map, it's the southwest corner of our country, like Arizona, New Mexico, Southern California, that gets great amounts of sunlight, and they can really rely on it. Here in Ohio, it's more like a supplemental thing. The biggest drawback from a hydroelectric power plant is the damage to habitats. And so what I mean by that is you have a river, you build a dam, now you have a lake. That is not the same habitat. And so some hydroelectric power plants have had big issues with endangered species and them being harmed. And then geothermal is my favorite. I think it's just awesome what Iceland can do with just the steam naturally coming out of the ground. But it is the most regional of all, meaning it's the most limited. You have to have a plate tectonic situation where magma is pretty close to your surface. And so here in Ohio, we don't have that to depend on fully, although it can be used still in Ohio as like a supplement in addition to other things. So sometimes students will ask, do I need to memorize all these? And the answer is, yeah, pretty much. Like you got to have a deep understanding of that, because I'm going to have you analyze graphs of changes in what we're using for electricity in our country. And you have to tell me what's good or bad about those changes. So, you really do need to master the pros and cons of all of those energy resources. Okay, let's finish up. We've mentioned this already. What gas is created when fossil fuels are burnt? CO2. Which gas traps heat? Of course, that's carbon dioxide. So we're seeing that connection, right, between the burning of fossil fuels and global warming. So what about this? Is the greenhouse effect bad? No, right? Is global warming bad? Yes. And that's the idea that we need some greenhouse gases or Earth would be too cold. Okay, now I'm going to slow down. 3 possible consequences of global warming. I picked the 3 from our song. So coastal flooding because of ice caps melting, farmland shifting, so the places where farmland is fertile moving north, and also more tropical diseases. But let me say this very clearly. I am fine if you tell me consequences from your image analysis. So you might have things like an increase in forest fires, an increase in billion-dollar disasters, athletes and outdoor workers struggling with heat exhaustion because of increasing temperatures, fish really struggling and having to migrate because of increased temperatures in oceans and rivers. So this is not an exhaustive list, meaning you might be right and then have picked something from our image analysis. Okay, so the final 4 questions are about actions and whether that's an increase or decrease in global warming. Planting trees. Our song says that that is something we should do because plants remove carbon dioxide during photosynthesis, so that's a decrease. Burning fossil fuels, of course, is an increase because it creates carbon dioxide. What about saving current forested areas? That's a decrease because you're preserving photosynthesis and plants remove our CO2. Do you see the thinking here? You always have to be like, does that make carbon dioxide or does it remove it? And then what about this one? Having laws to require cars when they're manufactured to get more miles per gallon, that's a definite decrease because you're in the end burning less fossil fuels, so that's less carbon dioxide that's emitted. Okay, so use this review to prepare for your quiz.